You know, when most of us think about artificial intelligence, we probably picture some high-tech lab or a massive Silicon Valley company. But what if I told you the next wave of AI builders aren't there? They're in a high school classroom. Yeah, really. Let's get into it. And look at this. This isn't just a poster for an after-school club. This is basically a call to arms for young innovators. The goal here isn't just about learning to code. It's about empowering students to use AI to tackle huge, real-world problems, like the UN's Sustainable Development Goals. The AI revolution, it's officially in session. So, how in the world do you take a concept as big as, well, as sci-fi, as artificial intelligence, and actually make it something you can teach in a high school class? Well, that's what we're digging into first. It all starts with the fundamentals, breaking down what feels like magic into simple, bite-sized pieces. Okay, first up is a core idea, computer vision. It sounds super complicated, I know, but the concept is actually pretty simple. It's all about teaching a computer to see and make sense of the world through pictures and videos, kind of like our own eyes do. But how does that even work? How does a machine see? Well, get this. To a computer, a beautiful photo isn't a photo at all. It's just a giant grid of tiny dots, or pixels. And every single one of those pixels is just a number. The AI's job is to stare at this massive spreadsheet of numbers and learn to spot patterns. Ah, that pattern is a face. That one's a car. In the end, it's all just math. Right, so you can't build a house without a hammer and some nails. And it's the same exact thing with AI. You need the right tools. In this next part, we're going to open up the AI Builder's Toolkit and see what these students are working with. This means getting really good at a specific programming language and using some incredibly powerful add-ons. And here it is. Meet Python. This is the undisputed champion language for AI, and for a really good reason. The code is clean, it's simple, it almost reads like plain English. That makes it the perfect starting point for students to begin turning their creative ideas into actual working programs. And look, nobody's expecting these kids to build Skynet on day one. Nope, they start right here with the absolute basics. The very first things they learn are simple commands, like one line of code to make some text appear, or a few more to add two numbers together. This is that classic hello world moment that kicks off every coder's journey. So, once they've got those basics down, they get introduced to something called libraries. Think of libraries as pre-built toolkits. Instead of having to build a car from scratch, piece by piece, you're just handed a high-performance engine, wheels, and a chassis. These libraries let students do really complex stuff without having to write every little thing themselves. Let's see how this all builds on itself. Here's a little example using NumPy, one of those key libraries. With this tool, a student can go way beyond just adding two numbers. They can now organize really complex data, like, say, the test scores for an entire class, into these neat grids called arrays that a computer can analyze in a heartbeat. Okay, so the students have the core concepts, they've got the tools, and that brings us to the really fun part, the part that feels like magic. How do you actually teach a machine to think? Or, well, to learn? This is where we get to the heart of AI. At the center of it all is machine learning, and it's all about a huge shift in thinking. See, instead of giving a computer a super strict list of instructions to follow, you just give it a ton of data and let it figure out the patterns and rules for itself. It actually learns from experience. And there are basically two main ways an AI learns. On the left, you've got supervised learning. This is where you give the AI data that's already labeled, like thousands of pictures of cats that are all labeled cat. It's kind of like a student studying with an answer key. On the right is unsupervised learning. Here, you just dump all the data in and the AI has to find the patterns all by itself with no help. Here's that supervised or teacher-led learning in action. It's a process called classification. So the algorithm has already learned what category A and category B look like. So when a brand new mysterious dot shows up, it can look at it and say, okay, based on everything I've seen before, that definitely belongs in category A. And on the flip side, this is a perfect example of unsupervised learning. It's called clustering. You don't tell the computer what a group is. You just give it a big pile of fruit, and it figures out all on its own, hey, I can group these by color or maybe by size. It discovers the hidden structure all by itself. Okay, so all this theory is super interesting, right? But it's all building towards something real, something tangible. In this section, we're going to see how students take all these new skills and actually apply them to solve real-world problems. This is where it all comes together. It's called the Capstone Project. You can think of it as the final exam, but instead of a multiple choice test, it's a challenge. Use everything you've learned to build a working AI that actually helps with a real-life issue. But here's the cool part. They don't just start coding like mad scientists. They follow this specific process called design thinking. And notice that first step, empathize. It's a totally human-centered way of doing things that makes sure they're not just building cool tech for the sake of it, they're building something people actually need. A huge part of building a solution is making sense of just tons of data. But let's be real for a second. How can a boring spreadsheet full of numbers ever tell a compelling story? How do you find the interesting part hidden in all that noise?
Well, it usually starts with something that looks like this, a CSV file. It's basically a spreadsheet. And for our human brains, it's just a wall of text and numbers. It's almost impossible to look at this and see the big picture.
And then, the magic trick. Using one of those libraries we talked about, Matplotlib, students write just a few simple lines of code and they can transform that messy wall of data into this, a clean, simple bar chart. And boom, instantly, the story is clear. You can see the patterns, the highs and lows. That right there is the power of data visualization. This all brings us to our final section. And honestly, it might just be the most important one. Because it's one thing to learn how to build AI, it's another thing entirely to understand the massive ethical responsibility that comes with having that power.
This is the big question. It's the one that every single student in these programs has to think about. Just because you can build something, does that mean you should? What are the real-world consequences?
And what's great is that this curriculum doesn't shy away from the tough questions. Students are taught to think critically about all the hard stuff, from biased algorithms to how AI might affect jobs, to our privacy, and even the safety of these systems. This isn't just a computer science class, it's basically a civics class for the 21st century.
So that's where we'll leave it. For the first time in history, we have an entire generation becoming fluent in the language of artificial intelligence. They're not just going to be users of technology, they're going to be its architects. And that leaves just one big question for the rest of us. What kind of future should we challenge them to build?